Hey there, year 11. So in this example here, we need to get used to reading the notation, the function notation, and then sketch it, and then you can then state its range. This is highly dependent on you being able to sketch all kinds of functions. If you still struggle with functions in general, I highly recommend you to use your calculator, and I'm going to show you how to do it as well. So for me, when I look at this, I know domain is from -1 to 2, and the function is a linear equation x. So on my calculator, this is how I would do it, okay? Even though in my mind, I know the graph has to be from -1 to 2, and I know it's a nice positive graph, so it has to finish off here, and it starts here and finishes there. So I know the graph looks something like this in my mind, okay? So then I would then say, this is 2 because I'm substituting when x equals 2 into the function. The y value is 2. And then same thing when x is -1, the y value is also -1. Okay, so that's my graph there. And so if I were to answer this question without using a CAS, I would have said the range, so y is an element of, clearly the range is from the y-axis, -1 all the way up to 2 is my highest value. Okay, so you can see that this is the lowest part of the graph and this is the highest part of the graph, and that's how I know, okay, what my range would be. So I would then say it has to be from -1 to 2 inclusive. Okay, so that's me, but for you, if you're not comfortable with sketching yet, then you should still know how to do it on a CAS, and I'm just going to clear everything. So again, if we were to do this from the scratch, menu actions, define f of x equals to x, okay? But I want you to practice putting in a condition. So how do you put in the domain? Go control and then press equals over here. Press equals and you got that vertical line over here. So you're saying sketch this graph f of x equals x given that, and then you can type in the domain. So -1, x has to be bigger than or equal to -1 because it's a square brackets there, so you include it. So x, or not w, x is then less than or equal to 2. So press enter. So that tells me I'm going to sketch the graph of f of x equals x, and it's only between -1 to 2. So when you see, if I go control doc, so add on a graph, you'll see now if I type f of x, it won't sketch a full line. Watch what happens, see? It only sketches portion of a line from -1 to 2, which is what I have over here on my OneNote, okay? But if I didn't do that, if I had just simply typed in f of x equals x, right? This is what the graph should look like without any restrictions. But I do have a restriction. The domain I'm working with is only from -1 to 2, which is why I had to put in that condition, and that's what the graph would look like, okay? So, and from there, how do you find the endpoints? Well, same thing. You know that the endpoints start off at -1, so you can do f of -1. That's how I got my -1, and then f of 2. That's how I got my 2 for my y values. I found by substituting x equals -1 and 2. Okay, so it's all hinging on you being able to sketch, and this is where a lot of students will struggle. I totally understand that there's a lot of skill here that relies on your previous skills, and you just got to work at it, yeah? So I'm just gonna do this one as an example again. So you're now doing x squared plus x, and your job is to get used to sketching this function. So this is a quadratic function, and if I were to do that, either CAS or by hand, same thing. I know this is an x squared plus x graph. I would have done some calculations first. So f of x, if I factorize it, I know that becomes x times x plus 1. So that tells me my x-intercepts are at 0 and 1. Okay, so I'm using letting y equal to 0, and you solve using null factor law. Okay, so that's how I know x equals 0, and then solving for that, x equals -1. Yeah, so all the way back to chapter 3. So I know that it's from 0, that's my x-intercept, and -1, which is over here. But they said that they only want my domain from -1 to 1. So -1, and then that means I can only get to 1. So my graph is likely to look something like this. Okay, and it's inclusive. So there we go. So I know it's a positive graph, and that's what I can see. So that's because I know the graph really well, so I can sort of visualize what it should be. So at this point, that's my maximum x value there. I'm just going to try to delete that. Okay. And so I just now need to know what the y value corresponding to that is, and I can work out the y value because I know x. If x is 1, I can find the y. So f of 1 would then be 1 squared plus 1, and that gives me 1 plus 1, which is 2. So that means that's my maximum y value there. But you see, when you're looking for the range now, clearly the smallest part of the graph or on the y-axis is clearly over here. That's my lowest y value, true? So I need to find the turning point. Now you can find the turning point in your own way, either the CAS or you can do completing the square, up to you. But I'm going to show you on the CAS how we do it again. So menu, define, menu action, so menu 1, 1. F of x is equal to, so I'm overriding the previous one, so it's x squared plus x, okay? And then control equals, given that it is from -1, where x is less than or greater than or equal to -1, but less than or equal to 1. So go back to my graph. This is what my graph looks like. If you want to zoom in properly, go menu 4, zoom box, so number 2, zoom box, and I'm going to select this corner to this corner just to zoom in, and that's what my graph looks like there. And I know that I need to find the minimum, right? So the minimum is down here somewhere. So menu 6, minimum, so number 2, and I just go left to right, and there you go. That tells me that the y value, the smallest y value there, is at -0.25. So I know this is at -0.5, and at this point here, this is -0.25. So my range, clearly my range here would then have to be y is an element from inclusive of -0.25 all the way up until 2. Okay, so really hinge it on the fact that you can sketch it. Once you can sketch it, you can analyze the problem. So all of these, I want you to sketch them and then analyze them on your CAS, probably, just to start off with, or to reduce the amount of algebra you do. Unless you want to practice those skills again on sketching, then go back and do them. So you do need to know how to do them by hand. So for example, C, you got the function from 0 to 2, 0 to 2 maps onto any number. F of x is a rectangular hyperbole. So if I were to quickly sketch this, you see in my mind, I know what a rectangular hyperbola looks like, but I need to work from 0 to 2. So rectangular hyperbole, we know that a rectangular hyperbole looks like normally like this. It goes on, right? And then there's this portion. But because they only want from 0 to 2, I can't have that portion there, and I can't have anything greater than 2. So it must go all the way to 2, and it stops right there. Okay, and this is an asymptote at x equals 0, and don't forget you get a horizontal asymptote at y equals 0 as well. So my only point I need to find out is right here, when x is 2, what's the y value, and how do you find out? Well, that's where you sub 2 in. 2 into the function, that gives you 1 over 2, so I know it's half. Okay, so that means the y coordinate goes from half, whoops, not -half, half, and it goes, the graph goes all the way up to infinity, because it will keep going up and never touches the y-axis and just keeps going up. So the graph, because it keeps going up, I know that therefore the range must be an element of starting from half to positive infinity, not inclusive. Okay, so your job is to sketch and then do it. If you can't sketch it by hand, do it on a CAS. But you can see how I'm using CAS or I'm not using CAS. Same idea. This is really to practice your sketching in general. So you can go back to chapter 3, 6, or 4 to get your head around cubics, quadratics, linear, or any other functions like hyperbole, rectangular hyperbole, truncus, and square roots. Okay.